Welcome to your lecture on organic functional groups. In this lecture, we are going to be looking at aldehydes and ketones. So, what is the general structure, formula structure for aldehydes and ketones? If you look here, when we're looking at an aldehyde or ketone, aldehydes only occur at the ends of a chain, and it is either going to be the end of the chain with a double bond O or both ends of the chain with a double bond O. But here's the thing. If I have a carbon and a double bonded O, remember that carbon has 4 bonds. So what goes on the other end of that carbon? Well, it's at the end of the chain. So that end of the chain then is going to be a hydrogen. Make sure you keep that in mind, okay? The ketone is only going to be in the chain. It is never going to be at the ends of the chain, because if you put it at the ends of the chain, then that ketone is going to look like it's an aldehyde. So notice the formula or the structural formula for ketone. You'll always have ketones on the inside of the chain, but you'll never have them on the ends of the chain. Okay, so keep that in mind as we go through this. Let's look at the aldehyde. The aldehyde takes the double bonded O again, and it is either going to be the end of one or both ends of the carbon chain. The naming of the aldehyde is the last name and then the main chain. So, what are the rules? First, you have to have a prefix for the number of carbons in the chain. Then the type of bond, whether it is an ane, an ene, or an ine. And then the end of that name is going to be Al for one charm or dial for 2. Now don't get that confused, because Ol is for alcohol. We're talking about Al. This is for aldehyde. That's where you get that Al from, the name aldehyde. Ol is for the end of alcohol. Al is for the beginning of aldehyde. So of the two, we're going to be looking at Al for aldehyde. So, if you need to pause the video for a moment and write those rules down, go ahead. Otherwise, let's go. So here's your first carbon chain with charm. Here is your aldehyde charm. Remember, I told you about the fact that hydrogen would be at the end of that charm. And let's see how many carbons we have and which is going to be carbon number 1. Well, the charm is going to give you priority. So this is going to be carbon number 1, 2, 3, 4, 5, 6, and 7. So that is a 7-carbon chain, which normally would be hept, right? It's got a single bond, so it's ane, so that's heptane. But because this has one aldehyde charm, there's that little rule that you probably have heard before. We're going to remove the E because there's only one, and we're going to replace that with Al. So if we did this right, this should be called heptanal. So let's see. And it's called heptanal. And just like I said, we drop the E from the alkane name, and we add al if only one aldehyde is present. Now take a moment and think. If we add al and we drop the E, if only one aldehyde is present, then if 2 aldehydes are present, what are you going to do? Are you going to drop the E? No, you're going to leave the E. Let's see it at work. Here, we have 2 aldehydes, one on either end. Does it matter which one is carbon number 1? Well, since there are no other charms on this chain? It does not. So we can still call this carbon 1, 2, 3, and 4. There are 4 carbons, so this is bute. It is a single charm, so that's A-N, but there are 2 aldehydes. So if we drop the E for one aldehyde, we're going to have to leave that E for the other aldehyde. And then we end it in di, because there are 2 of them, al. Butane dial. That's much easier to say than butanediol. Then you could kind of bite your tongue. Butane dial. So here we go. Butane dial. If you got that right, you're doing great. Let's look at another one. Look at this one carefully. How many carbons do you have? How many aldehydes do you have? Am I going to keep the E or am I going to get rid of that E? And what is it going to end in? You ready to check? Did you get propane diol? Did you get propane diol because you have 1, 2, 3 carbons for prop, single bond for an, E because there are 2 aldehydes, and since there are 2, di, and it ends in al. If you can just deconstruct this the way I just gave it to you, I think you're doing very well and you're on the right track. Let's look at the next one. Yeah, that's kind of long, but let's look at it. 2 aldehydes. Count the number of carbons. And then let's see if you got that right. Did you get octane diol? Once again, it doesn't matter which one is carbon 1. So 1, 2, 3, 4, 5, 6, 7, 8. So that's oct. Single bond. And there are 2 aldehydes, so the E stays there. And di for the 2 aldehydes, and then Al. So octane diol. Ooh, look at this one. This one is showing where all your hydrogens are. Don't let that throw you. That just means that this is a structural formula. It's not condensed. It's not a skeleton. It is a structural formula for this. You've got 1 aldehyde. Figure out where your carbon 1 is. Are you going to keep your E? How are you going to end it? Let's check. Did you get hexanal? Hexanal, because here's carbon 1, 2, 3, 4, 5, 6. So there's your hex. It's a single bond, so it's an and, but it doesn't have an E. Why? Because there's only 1 aldehyde, so it's an al. So that is hexanal. What about this one? Looks like it's hard, but it's not. Keep track. Remember your rules. How many carbons do you have? How many aldehydes do you have? Are you going to keep the E? You should get ethanol. Okay, now let's talk about ketones. Once again, that double bonded O is right there. But remember, it does not go on the ends. Okay? It does not go on the end. Again, the name is the last name, main chain. You must remember the location because a ketone charm can be at any location as long as it's what? Not at the ends. So we need to know where the ketone is located or where the ketones are located, how many numbers of carbons are in the chain, what type of bond is the carbon chain, ane, in, or ine, and since it's a ketone, it's going to end in O-N-E or one for ketone, or a Greek prefix for number of charms. If you've got 2 ketones, then it would be dione. If it's 3 ketones, then it would be trione. Okay? Now remember though, wherever that ketone is located, you must give me that number of wherever that carbon is. You cannot just say that I've got a carbon and a ketone on carbon 6, 7, 8, and 9. And then when you go to name this, you just call it a "own." No, if you have 6, 7, 8, and 9, that's 4 ketones. So its name is going to be tetraone. So keep in mind the numbering, keep in mind the rules, and let's see if we can do one. Okay, here we go. Here is your ketone. Remember, you cannot have ketones on the ends of the carbon chain. Otherwise, they're aldehydes. Okay, so here's your ketone. There's how many carbons? Which is carbon 1? Well, in this case, the end that the ketone is closest to, right? So this is carbon 1, still is carbon 1. You just can't have a ketone there. 2, 3, 4, 5. So this ketone is found on carbon 2. So this is carbon 2, where I found my ketone. There are 5 carbons, so this is pent. They are single bonds, so this is pentane, right? But there's only one ketone, so like the normal rule would be, we're going to get rid of that E, and we're going to put the O in E, which is on. So this should be called 2-pentanone. So let's check and see what we get. 2-pentanone. We're geniuses. We're absolute geniuses. Okay, let's look at another one. Oh, drop the E. We got all that. We got all that. This is the biggest thing you have to remember, I think, with the charms, is remember to drop the E when there's only one. Okay? And for ketones, make sure you put the Greek prefix, as well as if there's more than one tone. Okay? So dione, trione. I'm sure you're familiar with them by now. Look at this one. Where's carbon 1? Well, it doesn't matter because there's only one ketone away from the end, either end. Notice once again, no ketones on the ends. Why? Because that would make those aldehyde, and we're not doing aldehydes, we're doing ketones. So here's carbon 1, 2, 3, 4, 5, and 6. So on carbon 2 and carbon 5 of a 6 carbon, which is hex, with single bond, which is ane, I have 2 ketones. Well, do I keep the E? Well, if I take the E off, if there's one ketone, what do I do if there are 2? You keep the E, so that's hexane. How many ketones do I have? 2, so that's di, and of course the ending of ketone is on. So let's check ourselves. 2,5 hexane dione. Good job. If you need to pause the video to write some questions down, go ahead and do so, and then press play and continue. Okay. Ooh, look at this one. I'm going to give you a moment, see if you can figure this out yourself, and then come back and we'll check. This is 2,4,6 octane trione. Why? Where is carbon 1? Carbon 1 is here because this ketone is closer than this ketone to the end. So this is carbon 2, 3, 4, 5, 6, 7, 8. So on carbon 2, 4, 6 of octane, right, because there's more than one, there are 3 ketones. If you're getting this, you're doing just fine. Look at this one. Does it matter whether the ketone is up or the ketone is down? I don't think so. But look at it carefully. See if you can figure out what it is. Pause the video if you need to and press play. Okay, this is 2, 4, 6, 7 nonane tetraone. Well, let's deconstruct this. Where's carbon 1? Well, carbon 1 is going to be here because this ketone is closer than this ketone. Let me see if I can get rid of that little band. There we go. There we go. All right, so this is carbon 1 because this ketone is closer to the end than this ketone. So that's carbon 2, 3, 4, 5, 6, 7, 8, 9. So on carbon 2, 4, 6, and 7 of a 9 carbon single bond, non-name, and we're going to keep the E because there's more than one ketone, there are 4 tetra ketones on. Ah, there's one right here. First of all, you got to figure out what your hydrocarbon chain is. This is 1, 2, 3, 4, 5, 6. So we know that this is cyclo, hex, there's single bonds, ane. Now the question is, do we keep the E? Yes, because there's more than one ketone. Now where are those ketones located on that cyclohexane? Remember, with charms, you want to keep the number as low as possible. So if we look at this cyclohexane, we can make this carbon number 1, 2, 3, 4. So on carbon 1 and 4 of cyclohexane, we have 2 ketones. So it should be 1,4-cyclohexane dione. Let's see what we get. 1,4-cyclohexane dione. Perfect. And that ends your lecture on organic chemistry for aldehydes and ketones.